Let's talk about how to identify the different groups on a periodic table. First of all, notice that groups go up and down. These are your vertical columns on the periodic table. Might want to note that on your sheet. Vertical columns. These are sometimes called families. And some of you might recall that some of the groups on the table have specific names. But these are the groups going this way. This group is called the alkali metals, group 1. Group 2 is alkaline earth metals. If we skip across over here, this is group 3, that's the boron family. Group 4, the carbon family. Group 5, nitrogen or pnictogens. Group 6, the oxygen family or chalcogens. I'm not sure how to pronounce that actually. This group is the halogens, fluorine, chlorine, bromine, and iodine. And the last group is the noble gases. So those are the different groups. And you might notice the way they're numbered on some traditional older periodic tables. These are the numbers that are given in Roman numerals: 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. And these tall columns, all of these, plus the ones on this side, are called the representative elements. Okay, the representative elements are all the ones that end in A on your table. On the B groups, the ones that are shorter down here are the traditional numbering. This would be Roman numeral, like I think it's 2 or 3B, maybe it's 3B, and then it goes all the way to 1B and 2B. I haven't found those very useful in teaching nomenclature, so we're going to skip that. And then in some of the newer, more modern tables, they actually will number the columns straight across. 1, 2, 3, 4, 5, every single column all the way across to 18. And there's nothing really wrong with that, except that it doesn't help us with our nomenclature rules very much. So, I think we've been over that. Those are the groups. Periods are the ones that go across. These are your horizontal rows. And if you look on your periodic table, you can see there are 7 periods. They're all labeled. This group down here, these are called the inner transition metals. And they fit inside the periodic table right here. If you look at the numbering, it goes from 56 down here to 57, and then across to 70, and back up to 71. And so on across to 88, and then you come down here and do 89, go across the bottom row and come back here to 103. So those fit within this B section, the shorter ones. These are called the transition metals, or transition elements, and then these are the inner transition metals. So the tall groups are representative, and the short groups are the transition metals. And I think we have room on your notes. I would maybe say tall A columns. And for the transition metals, that's everything from scandium to zinc. See, here's scandium, and here's zinc over here. So all of that part in the middle. Okay, so pause your recording and take a minute, circle the transition metals. All the ones on your list that are transition metals, take a minute and circle those, and then turn the recording back on and we'll go over it together. Okay, these are the ones you should have circled: gold, silver, iron, copper, cobalt, nickel, zinc, and mercury. Calcium is in group 2A, Sodium's in group 1A. Those are representative elements. Antimony is in group 5A, also representative element. Lead and tin are in group 4A. Those are representative elements. Chlorine is in group 7A. Bromine in 7A, and neon in 8A. Alright, on the next section, you should know that metals tend to lose electrons to form cations. While nonmetals, guess what they do? They tend to gain electrons to form anions. Now, nonmetals can also bond with each other in a covalent bond, but we'll talk about that later. The noble gases in group 8A do not form ions. That's the ones over here. Helium, neon, argon, krypton, xenon, and radon. They're pretty unreactive. And in fact, that's what the word inert means right here. I-N-E-R-T means unreactive. Although there are a few of those that can bond covalently. For the charges, you need to learn to write the charges across the top of the table. So on your periodic table, this is +1. All the ones in the first group get a +1 charge. The next is +2. Next is +3. Let's skip 4A because these two tend to bond covalently, and the ones underneath can have more than one possible charge, so we'll not label the column. This is the -3 group, -2 group, -1 group, and the noble gases would have 0 charge. So what we're doing is saying when these elements form ions, little charged particles, most of them, you can tell, tend to be cations, and a few of them tend to be anions. And those are the ones that we've labeled for the representative elements. Notice that we did not label the transition metals. We're just focusing on the representative elements for right now. There's a nifty little rhyme you can say to help you remember what they are. To memorize it easily, it goes like this. +1, +2, +3, skip, -3, -2, -1, zip. And it rhymes. And that way you can memorize those charges. Okay, let's take a minute and practice with those. Write the charge as a superscript on the right of each element below. When we write a charge for an element like potassium, potassium K is here, it has a +1 charge, so I'm going to write +1 or even just a plus sign to the top of the potassium side on the right. What about lithium? Well, notice lithium is also in group 1, and so is sodium. So I'll write those the same way. +1, +1, or I could have just written plus. How about oxygen? Oxygen's over here in the -2 group, so it gets a -2 charge. So I'll write -2 there. Okay, pause your video, try it yourself, and then push play again when you're ready to check your answers. How do you do? Notice that I did not label carbon because it tends not to form ions. It does in some case form what are called carbocations, and then it's a +4 charge. Neon doesn't usually form charges either, so I would give it a 0 charge and not label it as an ion. Alright, one more section on this page. For each anion, remember that's the ones with the negative charges, for each anion above, write its name with an IDE ending below. So for example, the first one I come to is oxygen with a -2. It doesn't matter what minus sign it is as long as it's negative. We change the ending of the word to IDE. So instead of oxygen, it's oxide. So an oxygen atom would just be written as O and be named as oxygen. But oxygen with a -2 charge is an ion called oxide. So I can distinguish whether it's an atom or an ion just by the way I name it. Right, the next one on your sheet is chloride. Okay, try the rest yourself. Pause for a moment and then come back and check your work. It's really better if you try it by yourself instead of just listening to me do it. If you think through it on your own, you'll learn more that way. And here are your answers. Oxide, chloride, iodide, sulfide, bromide, nitride, phosphide, arsenide, selenide, and telluride.